Welcome back with another video on this channel. We are doing Advent of Cyber 2024 on TryHackMe.com. So this is day 8. As you know, we are very late, but we're still gonna complete all the tasks here by 31st of December. So let's get started. So in task 14, we have shellcodes, day 8, shellcodes of the world unite. We already have walkthrough here. We're gonna create our own. So here we go. Glitch the hacker, clever yet distrusted, wrote a script with skills finely adjusted. Shellcode magic to his home. It would send where secrets of Ware Valley he would carefully penned. Okay. Glitch, a skilled but mistrusted hacker, was prepping for a tech conference. He was eager to share his shellcode script that remotely access his home system. As he worked, he noticed mere malware's hatchman lurking nearby. Okay, so they wanted to, I think, steal his code or something. They are wasting their time. I don't have anything they would want. Glitch chuckled. Like he said, "Oh, I don't have anything to do with that." So I think he's wrong. Basically, he is trying to do a reverse shell or something like that. So what they could do, they can just steal the code and try to use it somewhere in their attack and try to pin that this code is written by Glitch. So Glitch is the main culprit. I don't know. I'm just hypothetically saying that. He did not realize that the hidden in his home system was something they desperately sought. A research paper he wrote on Ware Valley's defenses. Oh, okay. A treasure mere malware was eager to obtain. All right. So defenses mean it will have all the things like defense matrix and all the vulnerabilities or the attack vectors that can be utilized to, to prepare for an attack on the Ware Valley. Learning objectives: grasp the fundamentals of the writing shellcode, generate shellcode for reverse shells, execute the shellcode with PowerShell. Okay, PowerShell, that means we will be doing it on Windows. Connecting to the machine. Before moving forward, review the questions in the connection card shown below. So we need to start the attack box. I already did so. Here we go. I need to start a VM? I already started it. Is there a split screen available? Yes. Is there a direct link available? No. Am I given credentials to connect directly to the VM via RDP, VNC, or SSH? I can see the attack box, but where is the VM itself? Just a moment. Let me put it up in the split screen. So this is my attack box, and this is the actual the VM, right? Okay, so let me just exit the split view. Let's go back. Shellcode, and here is the okay, username is glitch and password is password. Okay, let's use that. Glitch. Remote TryHackMe. What happened here? Okay, password is with 0, not O. So let's copy paste that. Glitch. What is happening here, guys? Did I? It's not working. What is happening here? Why it is not working? Maybe I need to restart the machine or something. So here we go. We will try hack me, and here is the password. Yeah, it's not working. Let me terminate the machine and restart it again. Okay, machine is terminated. Let me start this machine again. Let's see what happens. In the meanwhile, let's continue. Okay, aside from the VM, you must also start the attack box. For this task, click on the Start Attack Box button located on the above page. We already did so. Essential terminologies. Reverse shell to his system so tight he planned to showcase at the tech conference. Knight, eager to share how his shellcode could impress, he aimed to enlighten, to teach, and progress. Okay. Before we start, review some important concept to help you better understand the upcoming content. Shellcode is an advanced topic, but knowing these fundamental ideas, we make the rest of the material more accessible and engaging. Shellcode, a piece of code usually used by malicious actors during exploits like buffer overflow attacks to inject commands into a vulnerable system, often leading to executing or arbitrary commands or giving attackers control over a compromised machine. Okay, shellcode is typically written in assembly language, really, and delivered through various techniques depending on the exploited vulnerability. It's not an assembly language. We can write the shellcode as per the language that the VM or the system that we need to attack. For example, if the system that we need to attack just support the PHP, then we need to go with the shellcode for PHP. If we support .NET, then .NET. If Python is there, then Python shellcode, right? I don't know why they put that it should be in the assembly language, because assembly language is very low level language. But let's see, maybe they are right. PowerShell, a PowerShell scripting language and command line shell built into Windows for task automation and configuration management. Before PowerShell, there was a CMD, and now everything is going through a PowerShell, right? It allows users to interact with the system component. It is widely used by administrators for legitimate purposes. However, attackers often use PowerShell as a post-exploitation tool because of its deep access to the system resources and ability to run script directly in memory, avoiding disk-based detection mechanism. Yeah, that is correct. Windows Defender, a built-in security feature that detects and prevents malicious scripts, including PowerShell-based attacks, by scanning code at runtime. Common bypass methods for evading Defender include obfuscating scripts to disguise malicious content, making it harder for the software to recognize known patterns. Another technique is a reflective injection, where malicious code is loaded directly into the memory, avoiding detection by signature-based defenses. Yeah, signature-based defenses is the legacy way of doing the virus scanning or malicious malware scanning. But now most of the systems are looking forward towards the behavior based scanning. So what behavior the malware represent while it is executing in the memory or on the system. The request connection does not exist. Please check the connection name and try again. Yeah, we are doing it. Is there any issue with the VM here? What about our tag box? Yeah, tag box is still loading and running. I hope. Now we can see the password as well. Here is the password and whatnot. And this is the remote machine. I don't know what is happening here. Why the VM is As per here, VM is loaded and it should be running, right? Not sure what is happening. What about my attack box? Even attack box is something going on, guys. I don't know what is happening here. Let me start the attack box. And at the same time, let me start the VM as well. Hopefully this time it will work. Okay, so we were here in the Windows Defender. So now most of the software basically scan based upon the behavior the malware or the software is depicting. Okay, Windows API. This is new. The Windows application programming interface allows programmers to interact with the underlying operating system, giving them access to the essential system level functions such as memory management, file operations, and networking. It serves as a bridge between the application and the operating system, enabling efficient resource handling. The Windows API is crucial because many exploitation techniques and malware rely on it to manipulate the processes, allocate memory, and execute shellcodes. Common Windows API functions frequently used by the malicious actors are including virtual allocate, create thread, wait for, signal object, which we will also use in this task for exploitation. Okay. What about the accessing Windows API through PowerShell reflection? Okay, so reflection is a technique where on the runtime you basically try to call a function on an object. If you know about the .NET, then you must know or heard about the reflection. The reflection is basically dynamic programming where you don't know which variable or the functions are available at the coding time, but you know that this function will be available at the runtime. Windows API via PowerShell reflection is an advanced technique that enables dynamic interaction, dynamic programming with the Windows API from the PowerShell. Instead of relying on pre-compiled binaries, PowerShell reflection allows attacker to call the Windows API function directly at runtime. This will enable them to manipulate low-level system processes, making it a primary tool for bypassing security mechanisms, interacting with operating system, and executing code stealthily. Stealthily means in a hidden way or cautious, or which the system does not suspect. Reverse shell, a type of connection in which this target, the machine you are trying to hack, initiates a connection back to your attacking machine. In this case, your machine will be the attack box. So the reverse shell is mostly there in the internal pen test, because you in a real world hacking, you don't want to expose your attacker IP address unless you are going through proxies and whatnot, right? So if a system is trying to connect back to your attacker IP address, that means if there is an investigation, you will basically expose your IP address. So most of the time it is not an IP address but a command and control server with that domain name. So, and domain name is changing the IP addresses every few minutes or something like that. So they basically mask the actual IP of the attacker. Okay. So this is how it will be done in a real world. But in our simulation, we are trying to connect back to our attacker machine, which is our attack box here. And we are also showing the port, which is Tetra 4. So in the real world environment, the port itself will be blocked because this is not the common ports on which the communication is allowed. For example, on port 80, or nowadays it is only on 443. Okay, maybe the connect back from one server to another is totally blocked. So there could be different ways you can use in order to have a reverse shell. Maybe you will use the actual application to do a web shell and use the web shell to connect back to your system, or you can directly use the web shell itself to do your nefarious, the exploits or whatnot. Okay, so reverse shell, we have attacker, we have IP address. This is the IP address, and we are trying to connect back on Tetra 4. So reverse TCP connection. TCP connection is created from our victim, which is the IP address is here, and we are. So how it did happen? So attacker sent some exploitation code to victim, and then victim connect back to our IP address, and that means we need to run some kind of listener on our attacker, so that once the connection is initiated, we will capture the connection and connect back to the victim. So we'll see, I think, here. So fortunately, our AOC shell coding v5 is available, and our attack box is also hopefully available. Okay, generating the shell code. Let's learn how to generate a shellcode to see what it looks like. To do this, we will use a tool called MSF Venom to get the reverse shell. Okay, so in order to do that, let's open up our shell. In the target box, open the terminal, enter the command MSF Venom -p Windows x64 shell _ reverse _ TCP L host, which is the attack box IP address. L port is they are going with the Tetra 1, and -f, which will basically generate the code itself, shell code. Okay, so let's try to do this manually, so we will learn as we type. Otherwise, if you just copy paste, your memory will not trigger, and that means you will not learn the command itself, and you will not build your memory. Okay, so attack box IP is already here. It's 10, 10, 180, and 150. 10, 10, 180.150. They want us to use port Tetra 1 and -f. Did we do something wrong? Error, missing required argument for option -f. What we are missing basically? What we are missing? Okay, let's try this. Let's copy paste. Yeah, we're still missing something. Okay, wait. -f PowerShell. Okay, we are missing the power. Oh, okay, there is a PowerShell as well. So PowerShell. Oh, wait. This is wrong. So this is the actual command with the IP address PowerShell. Now it should work, hopefully. The above command generates a piece of shellcode using MSF Venom. Here's what each part means. -p Windows x64 shell _ reverse _ TCP. The -p flag tells the MSF Venom what type of payload to create. Windows specific that we want a reverse shell for Windows machine. L host is the attacker IP address. This is the IP address of the attack box. It tells the reverse shell where to connect back to. L port, the listening port. This is the port number on your machine that will listen for the reverse shell connection. When the target connects back to you, it will use this port. In this example, we can choose any available port, but it needs to be matched with what your listener is set up to. Okay. -f is -f PowerShell. This specifies the format for the output. In this case, we want the payload to be in PowerShell format, so it can be executed as a script on Windows machine. Okay. Where is the actual shellcode? The actual shellcode is output above in the hex code byte array. We start with the 0xfs and then the rest of the words and so on. The hexadecimal number represents the instruction set on the target machine. Computer understands binary ones and zeros, but hex numbers are just a more human readable version. So instead of seeing long strings of ones and zeros, you see something like 0xfc. So it is assembly language. Yeah, we can execute the shellcode by loading it into the memory and then creating a thread for its execution. In this case, we will use the PowerShell to call a few Windows APIs via C# code. Below is the simple PowerShell script that will execute our shellcode. Okay, let's see what we have here. So we are declaring a variable and we are using C# code here using system.runtime.interop services. Then public class which will allocate, and we are loading a DLL kernel 32. Okay, then we have public static external virtual. Okay, we are declaring some public function, and it is a static function. I don't know if this is overridden from here. Let's see. And then we have add again, add type, which will allocate wait for add, and then we are creating another one, wait for single object. Yeah, I think this is overridden function, and we are also loading kernel 32 and then set loss error is equal to true. We are doing another one, wait for create thread, then we're doing the add type, then crt thread, and then here we have byte shellcode underscore placeholder. Okay, and then we have interptr, which is address, and we are running some kind of code here. We are mentioning the allocation in the memory, and then we are copying the code into the memory, and then we are creating the thread, and then we are waiting for the thread to execute. Okay, there's a lot of code, but don't stress, we will break down what it does step by step. Okay, if you are new to cybersecurity, memorizing these functions is unnecessary. Most penetration testers use pre-made or automated tools to run the shellcode. That is true. So you don't have to know every technical details to complete the job. No need to worry. Yes, if you are trying to do the pen test with pre-built tools and automated tools, then you don't need to worry. But if you are going to create your own malware, and if you want to, the existing code is somehow is blocked and you need to modify the signature, then you need to understand the code in order to create your own malware. All right. Explanation of the code. Script start by defining a few C# classes. These classes use the DLL import attribute to load specific functions from the kernel 32 DLL, which is part of the Windows API. The which will allocate this function allocate memory in the process address space. It's commonly used in scenarios like this to prepare memory for storing and executing shellcode. Create thread. This function create a new thread in the process. The thread will execute the shellcode that has been loaded into the memory. Wait for single object. This function pauses execution until a specific thread finishes its task. In this case, it enables that the shellcode has completed execution. Okay, these classes are then added to the PowerShell using the add-type command, allowing PowerShell to use these functions. Okay, storing the shellcode in a byte array. Next, the script stores the shellcode in a buffer variable, a byte array. In the example above, the shellcode underscore placeholder is just there to show that where you would insert the actual shellcode earlier generated through MSF Venom. Usually, we would replace it with the real shellcode represented as a series of hexadecimal values. Uh, these hex values are the instructions that will be executed when the shellcode runs. Okay, allocating memory for the shellcode. The virtual allocate function then allocates a block of memory where the shellcode will be stored. Instead of storing on the temp location, we are storing it in the memory. The script uses the following arguments: 0 for memory address, meaning that the windows will decide where to allocate the memory; size of the memory block, which is determined by the length of the shell code. Okay, we know that. 0x3000 for the allocation type, which tells the window to reserve and commit the memory. 040 for memory protection, the memory is readable and executable, necessary for executing the shell code. Okay, awesome. After memory is allocated, the marshal.copy function copies the shellcode from the buffer array into the allocated memory address, which is address, preparing it for execution, executing the shellcode, and waiting for the completion. Once the shellcode is stored in memory, the script calls the create thread function to execute the shellcode by creating a new thread. This thread is instructed to start execution from the memory address where the shellcode is located. Address. This script then uses the wait for single object function, ensuring it waits for the shellcode execution to finish before continuing. This makes sure that the shellcode runs completely before the script ends its execution. Time for some action. Executing the shellcode on the attack box. Execute this command nc minus. Okay, so let's do that. Let me open a new tab and execute it here. Let's type it. So we'll build our muscle memory. So nvlp. Okay, now our attack box is listening. Wait for the incoming connection. This command opens port on Tetra1 and listens for the connection, allowing the attack box to receive data once a connection is made. Okay, this is true. Okay, on the attack box, begin by navigating to the desktop. Right click on the desktop, select create a document and choose empty file. Sure. Okay, I did so. What happened? New file. Okay. Let's open it. It will be opened in Pluma. Okay. So let's go with the code we had here. Copy. Paste. And now here we need to paste our code. Once you have added the shellcode, navigate in the attack box, open. Okay, so here we need to replace it with the shellcode we previously created. So the shellcode we created was where is it? Okay. Here is the shellcode. Copy. Wait a moment. Let me make it a little bigger so it is easier to copy. Copy. Then we need to paste it here. So here we go. Hopefully this is what they want us here. Or we need to create it with quotation marks. Let's see. Once you have added the shellcode, navigate to the attached VM, open PowerShell by clicking the PowerShell icon on the task button paste the part of the code from the document you recently created to the Windows PowerShell window. For example, the first part of the copy and paste is the block below. Then paste the line below, replacing the placeholder with the shellcode generated by here. Okay. Continue copying and pasting the lines. Remember, copy one line at a time, paste it, and enter. Press enter. Okay, there is a better way to do it, by the way. Okay, so we can do one thing. There is a PowerShell ISE. So this will basically we don't have the password, or maybe we have the password. PASSWORD. Let's try this one. Okay, let's run it without. Okay, PowerShell ISE. So this will give you a very nice interface where you can copy paste your whole code there, right? So let's copy whole code and we will execute it one by one, maybe. All right, so click on here like this, and then you paste your code. Why the paste is not working, guys? Paste is not working. Yeah, paste is working now. Make it bigger. Let me make this one also bigger. Allow. Okay, now you can see. Then make it bigger as well. Okay, here we go. So if I click on run the script, it will automatically run the script. And here we should receive the connection, hopefully. All right, let's do that. I'll just put the cursor on the very start and then click on this button. It will run the full script. And let's see if we get the connection here. Right. If your PowerShell terminate and unexpectedly close it, it means your NC listener was not reachable, possibly because it was not running or was listening on the wrong port or IP. If you're done it properly, the PowerShell terminal in the VM will look like the screenshot below. Okay. It is saying that content and ad are blocked by your antivirus software. Okay. The antivirus software blocked it. Okay, let's do one by one. Let's go with here. Copy. Let's execute here. Let me increase the font size to at least 24, so it is visible to you guys as well. Let me copy here. Enter. Wait a moment. Let's go with the chunk by chunk as they told us. I think this is necessary. So add C or until add type C or T thread. Okay, so this is what we had done. basically. Let's select and execute the run selection. Let's see what happens here. It is running the script. Okay, script ran without any issue. Let's run this one line at a time. Okay, it runs successfully. Now let's run from here until here by using this run selection F8. Okay, just click on it, it will run, and in the meantime we should get the connection here. I hope I'm using, yeah, we got the connection, awesome. Let's see. Okay, ls is not recognized because it is Windows, so dir is recognized. Awesome, awesome, awesome. So we are able to replicate all of this, and we were able to get the connection, PowerShell connection here. Regaining access. Let's dive into the story and troubleshoot the issue in this part of the task. Glitch has realized he is no longer receiving incoming connection from his host base. Mere malware minion team seems to have tampered with the shellcode and updated both the IP address and port, preventing glitch from the connecting. The correct IP address for the glitch is attacker box IP, and the successful connection port should be Tetra 4. Can you have glitch identify and update the shellcode with the correct IP and port to restore the connection and reclaim control? Sure. So they are saying what is the flag value once glitch gets the reverse shell on the digital world using port Tetra 4. Note the flag may take around a minute to appear in the C users glitch desktop directory. You can view the content of the flag by using the command type and then the flag itself. Okay, we can do even better. Okay, so let's go with the dir. So these are the directories available. What if we okay, but we are looking for desktop, right? So let's go to the desktop, dir desktop. So we don't have anything here. Okay, let's go to the desktop. Is there any way to see all of the file? Okay, dir help, dir help, dir help. We don't see any flag here. Okay, let's try the type. Then see users glitch desktop flag.txt. This is gonna find the file itself. Okay, it will take a little bit of time. Okay, let's copy paste this one. Let's try if this will work or not. Yeah, we don't have this file basically. So let's see. Here we go. Go to the Windows. We go to the glitch. Here is the desktop, and we don't see any file here. So do we need to? Let's dive into the story. Troubleshooting the issue in this part of the task. Glitch has realized he is no longer receiving the incoming connection from his home base. Mere malware minion team seems to have tampered with the shellcode, updated the both IP and port, preventing glitch from connecting. The correct IP address for the glitch is attackbox_IP, and the successful connection port should be Tetra4. Can you help glitch identify and update the shellcode with the correct IP and port to restore the connection and reclaim the control? What is the flag value once glitch gets reverse shell on the digital wall using the port? Or the flag may take around a minute to appear. Okay, so should we okay, so should we basically update the code? Should we update the code basically? And receive the connection. Okay, let's do one thing. nc nv outp 444. Okay, let me make it a little bit bigger so you guys can see as well. So we are listening on the port Tetra4, and let's update our code to include the IP address. Basically we need to generate the code again, so let's use the same command. New tab, I'll paste the command, but this time I will change the port. My IP address is the same, so it will generate the code for us. I will copy the code, paste the code here, not here. We need to select exactly the same, and now I can paste my code. All right, so I will select all of it, copy. Let's go back here. So we'll use the same PowerShell which we used before because we can copy paste our code. Just run it and click on here, paste the code, and let me zoom in a little bit so you guys can see. All right, so on our attack box, as you can see, in here we are listening on port Tetra4, and we need to run it again without space. Okay, so let's select all of it, let's run it. We are running, as you can see, by this icon, and we can also see it is executed down below. So let it execute. Yeah, so once you get the prompt, that means the code is executed, and you can see here that the stop button is also displayed. So let's continue. Let's execute this particular code by using this button, run selection. We'll wait. Okay, now it is executed perfectly. Now let's run from line 38 to 41. Select carefully and use this button to execute. And in the meantime, let's go back. Yay, we received the reverse shell. So here we go, dire. We go inside the desktop, and let's go with the dire. Hopefully this time we will get the flag. So let's copy basic command. Let's see if or we can do one more thing, guys. We can do one more thing, which is just refresh here, because the file should be created here once we are listening on the port tetra 4. Okay, which is not available until now. Let's try this. Come on. Okay. Paste. We cannot find the file. We cannot find the file. So it will take a little bit of time, I think, in order to get the file here. So I'm gonna pause the video, and once the file is created, by default I will come back. All right. So until now I did not receive any kind of flag.txt, and the file is not created for some reason. Maybe we need to use the actual PowerShell here in order to see that. What is this, by the way? Let's see. This is something, but not related to us. So maybe we need to run our code in the PowerShell, not in the ISE. So maybe they are listening on, they have some script which is listening and try to create the flag once we execute a specific code. So let's try it. I am also searching in the Windows if there is any flag.txt. It is still working. So let's continue. Let's do that one again. So let's copy all of this and execute one by one. This time, come on. It copy. Let's go back. Let's execute. What happened? We are missing here. So we are missing. Okay, maybe it is not taking the whole. It is not taking the whole script. Let me copy it in the new text box here. Let's see. Yeah, it is taking all of it, right? Let's copy from here and try to execute. What is going on, man? Okay, it executed? Yeah, okay. Let me copy the rest of the code, which is from here until here. Copy, paste. Let's execute just this one. Right click. Okay, right click is not working. Okay, it's working now. Let me copy and paste here. Execute. Yeah, it executed perfectly. And then copy from here and copy. Okay. Alright, hopefully we will, yeah, we get it. And let's see if we get the flag here or not. So the flag is still not created. Maybe it will take 1 minute to do it. So in order to see flag is not found. And what if we go to the desktop directly? Yeah, flag is here. So this is the flag we are looking for. Okay. But we can still go here and try to execute the same. And here our flag is available as well. So what we need to do is to use the PowerShell itself, because the room is set up to listen on a particular PowerShell process in order to generate the flag. Okay, so we'll submit and here we go. Thank you guys for joining me on this journey. I'm enjoying it a lot. I think they need to make this task a little bit easier in order to help. Because if you are using anything other than the PowerShell, then this particular will not be able to find the flag.txt. But after debugging, we were able to find the flag.txt. So thank you guys for joining me. If you like this video, please give it a thumbs up. If you haven't subscribed, please subscribe to the channel. Help us build the community. If you have any comments, please mention it down below, and I will see you in the next video.